Beyond the academic pursuits, she is also the outreach network coordinator for the Indian Institute of Remote Sensing ISRO for conducting their outreach programs in collaboration with her institute. Along with that, she is also a resource person registered at National Geospatial Program of the Department of Science and Technology, Government of India from the year 2016. She has also delivered workshops and seminars on topics of geospatial technology, disaster management, and sustainable development in private colleges and universities as guest speaker and as visiting faculty. She has been awarded as Innovative Technologist and Best Professor in the 18th International Conference on Challenges and Opportunities in Research, which was held at Thailand in December 2019. The number of publications that she has is 16, 3 in international journals, 2 in national journals, 8 in conferences and symposiums, and 3 in international interactions. Now, I request Dr. Lahane sir to please felicitate our speaker of the session. I'm sure this session is going to generously add up to the practical exposure and applicability to real life problems. I now request ma'am to please commence with the session.
काम का पीपीटी मेल की है मेल की दो ना लेकिन डाउनलोड नहीं
Hello. Hello. Actually, Nasrat is
access और एक लेवल पे कॉल करके विदाउट डिटेल्स फाइल इसका सब कुछ है सचिन
तुम्ही डाउनलोड करून देता प्रेझेंटेशन
लॉगिन कर दीजिए हाय
presentation.
सुपर सुपर देखिए म्यूट कर दीजिए
तो पण मलाही आयडिया येईल की मी किती पाहू
or even if you are almost having your master's, so we are very much aware about problem formulation. But the little difference that we have or I have put up over here is the problem formulation or the steps that are involved in problem formulation. I have taken it in a case study. Like how the problem is to be formulated, how we have to look towards the problem, right? Design the problem first, and then what becomes easy is to how to acquire the solution or how to get the outcome that we want from that, problem to solve the problem. A little bit of remote sensing and GIS techniques I'll be telling because I guess this is the seventh day. No, fourth day, seventh presentation, and most of the all the presentations will be having on remote sensing and all. So here I consider that you know basics of remote sensing and GIS or whatever the technologies are there. In case I have put up a slide where I'll be explaining what actually this technology works on. But if you have any issues to you want to know more detail for that, you can definitely ask me at that time. Because considering this, repetitive, it should not be there. So I'll put only one slide where I'll be, making you understand about the technologies. Why? Because the next part is important is integration of the technologies. The beauty of this remote sensing technologies is it can be integrated, fine, and then competitive. Okay. So this helps us basically to solve the real world problems. How? To make decisions. So for decision making, integration of all these technologies like GPS data with the satellite data, with the software that you work in, isn't it? And with your physical, whatever mathematical modeling you do, isn't it? So all this becomes very easy because of this integration. So you see this integration of these technologies. And once we know about this problem formulation, and how this technologies can be integrated or can be separately used, okay, in combination, then is what we have the applicability to different problem domains. So I have considered here 2 to 3 problems which I have myself worked as a consultancy work or as my undergraduate or postgraduate students have done their work, research work a little bit. And one of the case studies where we have actually worked on a real world problem with the stakeholders that we have approached and then given a solution to that. And now that work is put up into a book chapter in Taylor classes. So this is some 2-3 case studies. And actually one challenging consultancy work which I have done, I would like to share it with you if we have time. But I'll be very much interested to share that consultancy work because it was very challenging with the, the terminal code where I had to present with this technology, how the wonders it creates. Okay. So this is the objective of any problem formulation. That is, you should know the concept of problem formulation. You should know its importance in research and planning, and very important is what are the steps that you have to follow during this problem formulation. And finally, to see to it that it is applicable to the real world scenario. When we talk about this remote sensing technologies, these are actually real world, technologies. At present, what is going on is what this remote sensing technologies gives you. Fine, because the satellites are continuously watching you, because you have your, mobile in your hand. That means you are having your continuous moving coordinates with you. And what else you require, isn't it? And all these things, when you put it in any software, fine. So morning का data analysis करके evening में आपको results मिल जाए. So this is how quick it is, isn't it? So the last one is how these principles are applicable to the real world scenario. So what is problem definition? It is a process of defining and structuring the research question, fine, to provide clarity of focus for investigation or plan project plan. Here in remote sensing technologies, like when you are using these tools and techniques, why it is important problem formulation? Because these tools and techniques, actually, when you talk about when you are using the software or some coding or anything, this is nothing but language information. Fine. Now the data is real, fine. But if you don't use this data properly, that is, if you don't carry out the investigation properly, you're not going to get the expected results what you want. Fine. Otherwise, any other research, you can formulate a problem. You can go on using whatever, basic from sciences to all these things over there and see to it some other outcome you have. Here you have the ground truth verification. You just cannot say कि अच्छा यहाँ से remote sensing का satellite का data लिया, यहाँ से GPS का कुछ लिया, mathematical modeling किया, outcome आ गया. That outcome should help you to make some real decisions, real world decisions. And when you're taking some real world decisions, that should be applicable, that should be, profitable, isn't it? It cannot be hypothetical. Fine. That's the thing, how problem formulation here is very important. Fine. तो बस मुझे क्या आउटकम चाहिए उसके लिए मुझे क्या प्रॉब्लम कैसे फॉर्मुलेट करना है. So once I formulate the problem properly, then is what I know क्या क्या यूज करना है geospatial को. Fine. It's just like when you are ill, isn't it? You go to a doctor. Fine. And doctor, surgeon, general surgeon. He examines you and just ठीक है you only you examine yourself and say थोड़ा सा cough है, थोड़ा सा खांसी है या थोड़ा सर्दी हो रहा है, running nose and all. You give your things that you are feeling based on your things and based on a physical examination. Doctor gives you थोड़ा सा viral है. But if it continues for a long time, you have to go to a pathologist, isn't it? So what pathology is? It takes data from you only, isn't it? Blood है, क्या है, isn't it? It will take the data from you. That is what is geospatial data. Okay. So physical examination we all do. We know we are there on the earth. So we know our mother earth, at least in the area where we live, isn't it? So we cannot just, plug anything. So we are doctors. But general surgeon, चलो ठीक है पता है ये के बारे में क्या क्या है ये तो देखता हूँ मैं यहाँ पे फ्लड हो रहा है, isn't it? Here we have some other problem. So we are knowing about it, fine. But when you want to make some decision on that, because the problem is, of a big nature, of a big scale, and you cannot just, have your own engineering, only civil engineering approach or only your domain engineering, and you can give a solution. So then you require more data. कभी अर्थ का और डेटा लेना तो पैथोलॉजिस्ट के पास जाना, so geospatial, fine. But then the other thing that is decision making, pathologist के पास जाके is it like the pathologist where you see you have malaria, कभी ये दवाई लेके pathologist ले लो, what type of malaria, how much it is spread, and what part of your body it is there, isn't it? It's not the diagnosis, doctor only can diagnose and then give you the exact dose, isn't it? So now doctor has said 2 patients with malaria, but doctor will not give on the same medicine only or the medicine at the same time only, considering the physical characteristics, considering the age, considering what the malaria spread it is, how much malaria spread it is. Doctor will decide patient A को ये dose देना है, patient B को वो dose देना है, right? But the decision making was based on the pathologist report. That is what here what we have is. Geospatial technology is the pathologist reports from us, fine. But if we don't do the investigation properly, isn't it? Then is what the decision making or the outcome that we have will be a problem. Because it should be not a hypothetical solution or the outcome that you get. It should be applicable to the actual thing because it's going to happen, isn't it? So maybe predictive modeling. Or maybe, whatever, what you say, solution, right? At present solution, you want to give some analysis you want to give. You have to give a, nearby accurate solution, right? That is the crux of it. So what are the 3 characteristics? You identify the issue properly, you prepare the pathway, structured pathway, and what are the actionable outcomes you have to work. So why it is important? Because when we think about problem to formulate, it helps us to clarify the purpose, fine, what we are actually doing. It saves our time because we know what we have to do. So when the doctor says you have to go to the pathologist and pathologist के पास जाके pathologist बोलेगा आपको कौन से test करना है, no. It takes only write some, tests for you, isn't it? And then you only cannot decide कि अरे डॉक्टर ने बोला नहीं ये फालतू का डॉक्टर बोलता है हम लोग नहीं करेंगे. They sometimes say but it's not like that, isn't it? If the doctor has told you to do a echo test, अरे मुझे तो यहाँ पे बुखार आ रहा है echo test से क्या होगा? We are not the ones, isn't it? So this is what is important. It saves efficient time and resources, and because we get the exact what do you say, the exact data what we want, isn't it? We get it. We plan it. ये ही data मुझे ये लेना है, ये period के लिए लेना, isn't it? And then what we have is feasibility. Feasibility of whatever problem I have to find. So that problem will not have only one problem. I can at the same time, once I know the nature of the problem, I can say I can go through this also, I can go through this also. That is what your Google Maps do, right? We all know Google Maps, what it does, visibility. You have to go from your destination origin A to destination B. It gives you other routes, ETAs, isn't it? Fine, same time, isn't it? Or how many minutes saved, isn't it? Or this roadblock. So it gives you all options. Fine. So this is what is the third point, feasibility, and very important is the measurable outcome. You can measure the accuracy of it, the precision of it. Fine. And if it is really applicable to the present real world problems. Okay. So let's see the steps now, because this is what here when it comes to geospatial technologies and problem formulation and its applicability, steps are very important. Though we may not stick to these steps exactly as it is, but if you really use these geospatial technologies for problem formulation and then how this geospatial technologies can be applicable, somewhere very generally you are going to follow these steps. Okay, so the first one is identify the research need or objective. Okay. So first and foremost is what is your objective? Right? What research you have to do. Okay. So for example, I'm going to present that also as a case study, but here one of the work that we did, one of my UG students, he stays in outside Mumbai, that is Panvel city was staying. I guess you may know about Mumbai or Navi Mumbai area. So Panvel, when we have the new airport coming, okay. So he stays in Panvel city in Navi Mumbai, and he stays in Khanda colony, which is near to the Patalganga river. Okay. He once came to me. He was my elective student where I teach this remote sensing and GIS. So he came and he asked me, "Ma'am, can I use this technology to solve one problem that my colony or nearby this new Panvel city is facing?" So what was the problem is they are getting an order, okay, smell, fine, during the night time. Okay. Not only this, they have breathing issues also. Smell के साथ breathing issues भी है, and the complete new Panvel city is next to the Patalganga river, and next to this Patalganga river there's an industrial zone. Okay, fine. And then next to this industrial zone, there's also a MIDC area. There's also a testing lab with treatment lab proposed by the government itself. Okay, so MIDC का खुद का treatment plant है. Industrial area where we have lot of industries there. Reliance is one of it. And then we have this new city, residential area, New Panvel city next to this river. They used to get this smell, fine. And also they had some breathing issues in the morning time and all. So he said, "Ma'am, hum sab face karte hain. We have put this complaint, written complaint to the corporation. Fine. 2-3 times we have put up, and then they say ki you must be facing it due to some other problem. Fine, it's not because of the industrial area that we have and because of something may be happening that you doubt something may be happening in the river because of this industrial area. That's not an issue because the results, the tests that they carry out, okay, for the water sample from the water body, isn't it, are good are within the standards, is what they used to get the answer. I said, "Ma'am, as a citizen, as a stakeholder, we can just put up, we doubt this may be the thing, industries कुछ untreated chemical waste dispose कर रहा है river में, and that can be an issue. So we can only doubt. We don't have any proofs for that. If you do physical, the medical test and say कि बहुत लोगों को यही problem आ रहा है, then they would say कि it's not only because of that river problem or the disposal, what you say, it may be some other issue also, right? So you cannot guarantee. You should have a proof. Fine. That is what one of the officer that said that कि आप भी कुछ टेस्ट करवा लो, आप भी कुछ करवा लो वहां से और वो proof के साथ आओ कि this is happening because of the industrial waste. So can we use this remote sensing technology for this? So this is what we have. Identify the research. So identify the research need or object. So the need was here very need was I had to give them an outcome using this geospatial technology, but the outcome says कि yes, there is some problem in the river happening, and this is the proof you see. And this proof cannot be denied. Fine. Because if I do some test, they will say कि आपने पैसा देके जानबूझ के वो test, you have made that test accordingly. So that cannot be done. So we have to have a proof which they cannot deny. Okay, that yes, there is something happening there in that stretch of river. Fine. So what was the need? I had to give that exact outcome. Fine, which they can present it to the corporation. Now coming to this story, here I have provided a story where it says the problem, the broader context, the scenario that is put up over here is flood risk in an urban area, and what is important, broader context is preparedness. Fine. So why to do this risk? Why to do this risk analysis? To give them the preparedness for a long term, isn't it? That was it. So disaster preparedness, flood risk, and where in an urban area. Okay, so this was the broader context, the existing scenario. And then what we had is second step. Identify the parameters or scenario or the indicators for the outcome that you want. What is the outcome here? Flood risk is an outcome. Fine. Where it is for flood risk for an urban area. So what can be the parameters or indicators that is to be considered? Fine. You cannot skip any parameter there. You skip it and your risk analysis is, not that accurate. So when I say accuracy है, तो आपको parameters, indicators क्या-क्या data चाहिए, वो भी उतना ही accurate होना चाहिए. Got it? That's the reason we go for, first option, second option for, our health purpose. If you have to do something, surgery or something, we definitely take, 2-3 options from 2-3 doctors, isn't it? To decide upon. एक ही doctor के पास जाके ठीक है, ये बोल रहे हैं, वही we can don't do. So why? Because the indicators or the parameters will change, isn't it? But that should not happen here. If you want to really do a very good problem formulation and you want to have a real world outcome, isn't it? With a greater accuracy, what you have to do is you have to consider all the maximum parameters that you require. So here basically risk is what? Risk is the product of hazard and vulnerability. Fine? That I know. Risk is hazard into vulnerability. So what I should know, I require parameters for hazard calculation. I require parameters for vulnerability calculation. Now in that parameters, I should not skip or should go in detail of the parameters. Fine. So here for flood hazard, all the environmental parameters they have considered. What is the parameters like slope, direction, that is aspect, the rainfall, curve number, fine, elevation, land use, drainage density, urban drainage density, fine, distance to the drainage. Isn't all these parameters is flood hazard related. Okay. Then when it comes to the stakeholders, fine, stakeholders. क्योंकि urban flood risk है, तो stakeholders will be affected and hence lesser risk, isn't it? If it would be on an open land, flood आता तो किसी को risk है ही नहीं, isn't it? Just like earthquake, barren land पे आ जाए तो it's not a risk, it's just a phenomenon. Is it natural risk? Fine. But if it is affecting our, day-to-day, whatever our routine it is, isn't it? Or, the movement, it is at risk. Fine. So the vulnerability when we call the socio-economic vulnerability. Like if an area is population for very highly dense, कम flood आए तो भी problem है, isn't it? The flood inundation, थोड़ा भी पानी है लेकिन density बहुत है population वो area में, it is a risk, isn't it? Then what we have, urban density, a big broader area, fine. Then what we have, quality of the buildings, age of the buildings, and what we have is the socio-economic conditions, that is income groups. Slum area hai, middle income group hai, isn't it? High rise buildings hai. So the flood risk scenario will be different for these income groups also. So these flood vulnerability parameters, we can go on adding it here. But now in this paper, what they have done, they have considered these parameters that they consider very important. They feel so important for the risk analysis. And then based on these parameters or whatever the outcome, what they want is the flood risk map. Okay. अभी ये डाल के immediately नहीं मिला है. This is the last outcome that I have put up here. But what is expected is what you should know. So what you expect, what should be your outcome? Your outcome should not be give the population density. Your outcome should not be urban drainage state. Your outcome is risk map. So when I give this risk map to any layman here, isn't it any of the stakeholder here, and that stakeholder knows my location, that is his location, he or she can say whether it is in at very high risk or at low risk. If they know that they are in a low risk, fine, okay. They know where the high risk, they'll avoid that area. Isn't? If I know I am at high risk, I'll prepare myself for. That is what disaster preparedness is. Then comes the mitigation and strategies that you plan. You know, high risk है, लेकिन slum area है, then the corporation takes into, comes into picture and helps them. But if it is in a high rise buildings, high income group, then they will only inform the society people that you have to take care. Isn't it? They will not provide them everything. Right? Same thing happened in Corona. COVID में क्या था? जो slum areas हैं, low income areas हैं, the corporation were providing complete support to them. Isn't it? Food से लेके सब कुछ. But middle income, high income में है, putting the banners in the society. Isn't it? कि ये society में COVID infected है. Isn't it? या फिर ये society में whatever the things that they have planned, isn't it? This society should come out at this time only. तो मुंबई में तो हमारे यहाँ पे यही था कि क्लस्टर एरियाज किए थे. So this area they should come out for whatever the shopping or something at this time only in this time only. So that was done based on the income groups. Fine. So this is how you have to prepare this flood risk map, which will be used for disaster preparedness. Now next is defining the scope and
That toxic method is used for.
pardon?
Toxic method.
Huh.
Are you working with AHP?
Yes, we'll come on next.
Okay.
It is working on SP, and here when you come to decision making, but for non-spatial attributes, like you can see here, the socio-economic variables, right? We go for AHP.
Okay.
There are other methods also, but AHP is far better.
Toxic and AHP are alternative methods.
Alternative methods. But here, if you say in this type of, what you say, urban floods or earthquake risk or something, we prefer AHP.
Okay. So which one is this one?
I can say when it comes to the first level research, you better go with AHP. It's popular, it's easily understandable, it's easily executable.
Explain that flood risk map.
Mhm.
So is it the case that the person who generated that map differs from person to person, and if a person what falls at a high risk, what is falls at the low risk, or part some other.
It doesn't differ on the analysis, fine, because we have models applied. And that models, as sir said, we have to use popular methods which are acceptable or which are known to every researcher. So first level research, when you work out, you go by the popular methods, where this modeling is done based on these parameters. What differs is these parameters. You skip any parameter, isn't it? That is maybe important, it would be important, but you skipped it, that will affect your model accuracy. And that is how person to person it will differ. Yeah. Now, the scope. So once you know your problem, you have to define the scope of it, find the extent of it. So it can be the extent, it can be geographic extent, it can be temporal extent, or it can be a thematic extent. So thematic, here it is thematic extent because you are going only for floods. Okay. So क्या है theme? Flood के लिए ही करना है. But you can have multiple, disastrous risk mappers. Right? So for example, if I want to make Mumbai city ka risk map for all the disasters, I can make one map also, which says कोई भी disaster है, this location is high, this location is at low risk, fine for overall disasters, earthquake के लिए, flood के लिए, cyclones के लिए, because Mumbai is prone to all this, hazards. But this is thematic, like you take one thing, right? So flood is thematic. Temporal, when I say, you have to define the scope. See, when I say flood inundation map, so flood inundation map will depend, as I said, the hazard parameter was rainfall data. So rainfall data for what extent, what period you are considering, right? अगर आप 10 साल का कर रहे हो तो आपको डेफिनेटली वेरिएशन कुछ अलग मिलेगा. यू आर टेकिंग इट फॉर 20 years, there will be different variation. You are considering for only 5 years, there will be a different variation. Maybe because last 3 years, 5 years में बहुत बारिश हो रही है randomly, isn't it? Because of that El Nino or whatever effect it is. Fine, last year तो randomly बहुत जगह फ्लडिंग मतलब ब्रॉड होता है वहां पे फ्लड हुआ है. So you cannot go for very small time data, I know. लेकिन करना है तो कौन सा 10 years, 15 years, 20 years, again it is on you. Okay. So the risk map will change based on the extent, temporal, right? And then geographic. Like I consider the complete Aurangabad city or consider only, one area of it. Fine. Got it? I can bifurcate it and put it on small area. Okay. और यही area के लिए area wise map I can make it out. For example, if I talk about, because I don't know about Aurangabad city corporation how it is, but Mumbai we have wards. There are 26 wards. Complete Mumbai city is divided in 26 wards. So what I can make is one complete map for the Mumbai city itself, or I'll make ward wise risk map. Isn't it? So that ward wise risk map will be very easy for the corporation to deploy its resources कि ये वार्ड में बहुत लो लाइन एरिया है, यहाँ पे फ्लड्स बहुत है, यहाँ पे रिसोर्सेज ज्यादा चाहिए. Fine. So this is how you have to decide upon the geographic estimate. And then comes the acknowledge the constraints. Data constraints. So I say I want 50 years data, लेकिन available है क्या? Geospatial data you have a limitation. It is not available for the past data. Though it is available, it is not available for a very longer period. Fine. So this is where we have the constraints. Sometimes some of the data which we require high resolution data or something, we have to give the intent to the remote sensing centers and we have to acquire from them. It is not openly available. Fine. Then in that case, whether they will permit that data to me. Again, coming to Mumbai city, Mumbai is a restricted area. Fine. So most of the time, the data that we require, the special data, for the Mumbai city itself, vulnerability risk maps. And I wanted some data and I'd asked Survey of India, they were not giving me. Okay. And in that, Mumbai city complete is not actually one Mumbai city, it is two parts. So आपको जो maps मिलते हैं, fine, the what you say, paper maps here. There are two maps of Mumbai city. One is Mumbai suburb and the other is actual Bombay city. That is South Mumbai, we call it. So when I have to work out for the complete Mumbai city now, actually it is, isn't? अभी तो पूरा Mumbai city है, जिसमें हम लोग बोलते हैं suburbs है ना. But when you work out the corporation is complete for the Mumbai city, fine. So I have to merge it. तो merge के लिए दोनों data, one I get it from Survey of India, one I get it from remote sensing center. Then दोनों का compatibility भी अलग है, fine. That are some constraints that you have when you use geospatial data, and that is where people go wrong. Fine, because yes.
Ma'am, I know the various parameter which is required to generate the flood map
Yes.
at the at the upstream of the dam or reserve.
Okay.
I know the parameters. I know how to generate the flood map on the upstream of the dam or reserve. But can you explain
On the upstream side,
upstream or anywhere in between? That's
see, if you're upstream side of the dam, you're saying. डैम के अपस्ट्रीम साइड में आपके पास डेटा होगा, आपको फ्लड जनरेशन डाउनस्ट्रीम साइड.
But I'm little bit confused about how to get the data for generating the flood mapping. Growing.
Okay. We'll come to it. As the cases goes on, you will have your problems also, because if I tell you now, तो ये पूरा presentation का मैं आपको बस इतना समझाती रहूंगी. But as the cases goes on, we'll come to know how to consider the extent, how to consider the growth also. I'll come to tell you. Okay. Coming back to this problem, that is a constraint. I'll tell you right now, my undergraduate students are working on stormwater management for our educational campus. What they did is they did a physical survey. Civil engineers here you will come to know, we do the physical survey, we get our elevations, fine, and they have done it and they have got whatever the point data that they have, isn't it? And for that they have generated contours. Now, see, this is what we have to do the field survey. लेकिन अगर field survey करना नहीं है, मुझे preliminary देखना है, so I can take it from the GPS data. Satellite से, we talked about, we call it as Cartosat DEM. Cartosat is one which provides the DEM, digital elevation model. So I can download that digital elevation model, fine, and I can generate contours also from them. Now what happened is they did a ground survey. तो ग्राउंड सर्वे में उन्होंने कैंपस के पूरे पॉइंट्स है, फॉर एग्जांपल ये इतना रूम है तो ये रूम के कितने एक 20-30 पॉइंट्स ले लिए, उसके लिए कॉर्पस जनरेट. नाउ दिस 20-30 पॉइंट्स मींस रैंडमली दे हैव टेकन, फाइन. सो वी हैव वन स्मॉल लेक इन आवर कैंपस, वी हैव स्मॉल hillock in our campus, then there are various educational buildings there, fine. And थोड़ा सा लैंडस्केपिंग किया है मैनेजमेंट ने, so we have some landscapes going around the roads and all small gardens and. Now, when they took the ground survey, they did the contours. Now they wanted to, produce it from the DEM that is available from the satellite data, and they want to compare with the contours that they have done with the ground survey. Fine. Why comparison? Only when I compare with the ground survey, see this is also the ground truth, and this is what I have got through satellite. So we ground using my satellite data use karo, is what their point was to prove. Okay. Now, why to waste time in ground survey? Use the satellite data. But then how you can say only when you compare, right? So they downloaded the DEM and they generated this contours. Yesterday only night I had a meeting and they were showing me the contours. So contours here through the ground survey are going parallel this way, and the contours through DEM are going this way. Why this happened? Got it? This is where the crux lies, the constraints and the technology that we are using. Ma'am, so basic we are not knowing it and all. We told them which cartoon set DEM, which year you have downloaded. ये 2010 का है, but अभी यही available मिला हम लोग. Fine. Now our campus was redesigned in 2015. Okay, पूरा landscape change हो गया उसका. अभी उन्होंने DEM लिया 2010 का और ground survey किया अभी का, जो change किया है उसके बाद वाला. So will the contours match? बिल्कुल नहीं मैच होगा. Fine. So now that we have a small hillock over there, initially it was जो natural hillock था वो बहुत बड़ा था. Now that cut off, chopped it and made it, artistically, there will be definitely something different, isn't it? Some routes were not there at all. रास्ते थे ही नहीं कैंपस में अंदर, वहां पे अभी रास्ते 2015 के बाद किए उन्होंने internal links. So these these contours will not match. So you should come to know if you are really going for comparison, especially with the ground truth, तो भी आपको अभी का data लेना पड़ेगा. Right? Yes.
As of now, we can calculate by the analytical method, we can forecast the data.
Yes.
So same as it is, can be do by the spatial data.
Which forecasting?
Any data, suppose digital elevation pattern or the ULC map. Whenever we have the map of 2024, I just want to compare for 2028. Shall we?
This you can do on, like for example, right now, our Bhiwandi area is developing nearby the highway that is proposed. They are developing it. I can make it out, sure, based on the growth rate. Fine. Imageries में लूंगी वो एरिया था जब भी कुछ नहीं था, और बाद में उसके बाद हर एक ईयर में जब से थोड़ा डेवलपमेंट हो रहा है, from that I can work out a growth rate, and that growth rate for whatever population can extend over there, for population I can make it out, and for that population how much area can be enclosed based on itna population density I can make. But if you say so for the elevations and all, ground parameters, अर्थ के पैरामीटर्स जो कुछ एक्चुअल नेचुरल है वो हम प्रेडिक्ट नहीं कर सकते, फोकस नहीं कर सकते. लाइक एलिवेशन यू कैन नॉट फोकस, इट्स मैन मेड, बिग चेंज ना.
For that, I have gone through the train analysis for the long-term analysis of all the tiles of particular area. Then I just identify that, suppose here you will see, it is rising the urban area.
Yes.
With a percentage, somewhat percentage. So
Right.
that percentage I have taken for the forecasting.
Yeah.
You will see, but same thing is happen with my model also.
Hmm.
That digital elevation model doesn't match with the future. So that is
The time frame that is needed to be selected is very important.
So that's why I've taken the statistical analysis, plan with plot statistics that is
Elevation data and all, see, whatever it is, the ground data is there and we get it from the sun. We cannot forecast that. Fine, that can change naturally or that can change by whatever we prefer. Fine. So for example, we have this highway corridors going. So highway corridors, जहाँ पे जा रहे हैं, maybe even through the forest cover or semi-forest covers and all, the forest cover is also changing. Fine. So that I cannot focus. Okay. But having said so, if I know कि ये highway corridor जा रहे हैं area में, this is a vegetative cover. How much vegetative cover I am going to lose because of this? I can work out. But naturally I cannot, say कि ये change हो जाएगा उसके बाद इतने साल, and we cannot do. Okay. So here, considering this time thing or the geographic extent and whatever constraints you have, many a times when we have to do this work and we have to give it to, as I said, we have to put it in the code and all, it should have, the accuracy. Fine. So in that case, we really require data which is not openly available. Openly available में constraints होते हैं. Openly available data में what constraints I'll tell you as we go on it, and there are a lot of constraints that we have. So then what we do, we have to put it to the government and we have to ask them. So in that case, what happens is budget. Fine. So is the government or is the client ready to spend that much amount on that, data to take it? Fine. That is important. Fine. Sometimes we require special softwares. Fine. So here again we have two categories. Geospatial technologies, open source bhi hai, and you have, what you say, restricted one, or what you have to, give the intent and take it high resolution, high coverage and all. Fine. Here what we have is sometimes softwares, some softwares, open source softwares we have, which we can work it, but again, accuracy utni nahi hogi. Fine. Sometimes we have to go for licensed softwares like RS GIS, it costs around 18-20 lakhs. Fine. So this is how budget constraint comes. And again, technology, how accuracy, how high-end technology you require. Like if you want to put AI/ML into it, you can definitely put AI/ML in geospatial technologies also. Fine. Machine learning to use करते ही हैं बहुत सारे. Fine. Nowadays, a small part of AI is open to us. Okay, but high-end what we require for machine learning and all, that's not open, but we have to, purchase it. Okay. So that is how budget and technology and data comes into it. Now again, coming to the same, that problem we are continuing, okay, that case study, that is the urban interface. So now here again, as I said, temporal geographic extent, they have considered this mapping is done for one city in Iran that is called as Rash. Okay, so Rash के लिए this mapping they have. So geographical extent क्या है, पूरे ईरान नहीं किया उन्होंने, they have considered one city. Okay, now वो city के लिए 1000 parameters क्या किए, social parameters, whatever social parameters we have considered, we have done. Now what this do is flood vulnerability map. Okay, vulnerability parameters को लेके vulnerability map they have worked out. So now for doing this vulnerability map, what can be my extent, what can be my limitation, or what actual data with a very common sense I require, I'm going to check out. So here if you see in this map, this is flood vulnerability map, city of Russian Iran. You can see the elevation. Okay. Green one is low elevation and red one is high elevation. So you can see, if you see the city, the boundary, fine, is high elevation. Okay. And this portion, complete green, is in low elevation. Fine. Now if you see the streets, okay, street part, you see here there's a huge street network. यहाँ पे streets है ही नहीं. So if there is a street network here, that means this is the urban area. Got it? ये urban area. Right? Okay. So this complete urban area is in low elevation. The flood risk है, common sense है. Right? Now you see the river. Okay. This is the blue wala river that is going. Fine. This one, and it is again one river going here. What do you see? The river is going through the city. Right? Okay. Now considering this city boundary, considering the urbanization, considering the natural feature that is a river extent, you can see the flooded points and the non-flooded. Non-flooded points are in blue and flooded points are in red. So red points you can see, where are they located? In the city itself. And again, if you see the spread of these points, it is nearby the river. You can see यहाँ पे red points ज़्यादा है, यहाँ पे red points ज़्यादा. Fine. That is what common sense also says. वो तो किसी और को डॉक्टर के पास जाने की भी जरूरत नहीं है, राइट? सो रिवर है। अर्बन सिटी लो लाइन एरिया में क्यों है? क्योंकि सिटी कहाँ पे स्प्रेड होगा, सेटलमेंट कहाँ पे होगा? वेर यू हैव अ नेचुरल वाटर बॉडी, you have the river वहां पे ही होगा, isn't it? And that's how it grows, right? So this is the vulnerability map. Exactly from this also I come to know where can be the high risk of flood and where can be the low risk. But we have to consider all the parameters. So you can see again here land use. Fine. We should know also the land use for the flood. हाँ ठीक है, urban city है, urbanization है, उससे I cannot make it up. कौन सा land use sector है which will be affected by this, right? So if you see here, this green again, so is this 25% that is agricultural. So the outskirts you can see there you have the agricultural fields, okay, that is the vegetation. 34% is again the urbanization. Okay, fine. So even if I say 34% urbanization, if you see here it is residential area. So residential area will be the one which will be highly impacted if there's a flood risk. And if missed, there will be a flood risk because it is at low elevation. And next what you have is this 5% is barren land. You can see some pockets of this, barren lands here in the city, again, outside the city. Then you have some offices that are blue in color. Okay. So all this land use, once you know, you can exactly work out which sector is going to be highly impacted. Why? Because we are working on the preparedness. Right? Okay. So then next data what we have, flood का vulnerability क्या है based on the elevation data, based on the natural water body that is going on, based on what sector it is there. Right? So land use पे, elevation data पे, natural body पे, all this data when we have, in addition to this, we require rainfall data. क्योंकि flood कब होगा? Only in the rainy season, isn't it? Or else अगर कुछ डैम अपर एरिया में है सिटी के नेक्स्ट इसमें और वो डैम का कुछ हो जाएगा प्रॉब्लम तो ही फ्लड, अदरवाइज द वेट सीजन इज व्हाट वी से कि देयर विल दैट प्रोबेबिलिटी ऑफ हाई फ्लड्स. ओके, सो कंसीडरिंग दिस रेनफॉल डेटा वी हैव टू कंसीडर. नाउ अगेन ये रेनफॉल डेटा तो जियो स्पेशल से मिलेगा नहीं, so we have to go to meteorological organizations, right? Meteorological department say we have to consider the data. Now when you have to consider data, again as I said, accuracy depending on what amount of data, what temporal extent I consider. So if here they have considered for 20 years, they consider for 5 years, 10 years, 15 years, 20 years. Okay, or research में क्या करते हैं, we go from smaller duration time period to high time period, then check out कि क्या probabilities. Fine. Okay, here they have considered 20 years data and they saw that the rainfall variation for this 20 years is from 1227 to 1263 mm per year. Okay, you check out only Aurangabad city law. The rainfall is hardly 700, 750 per year, average annual rain. यहाँ पे तो flood का कोई issue नहीं. But if you talk about Mumbai city, like us, fine, we have average annual rainfall of 2,200 mm. So we must have seen even on the news channels or in the news. Every rainy season, Mumbai बंद हो जाती है, once or twice at least, complete बंद, because it's an island. Again, it is a saucer type. जो suburbs है वो बीच में है, ये जैसे था एक्टिव सेटलमेंट वैसे ही होता है. फाइन, तो जहाँ पे लो लाइन एरिया होता है वहां पे ही सेटलमेंट ज्यादा होता है. So Mumbai also it's an island type. When you go to the shores, that shore levels are higher than the city level. Okay, right? So when you have this type of thing, definitely you will have, high risk. So rainfall data. Now this rainfall data is not available. Like आप अगर IMD के पास जाओगे तो आपको rainfall data ऐसे layer में मिलेगा नहीं, map में नहीं मिलेगा. They will give you a Excel data or whatever they have the paper data with you. Put it, you have to map it. So this layer you have to create, which will give you the rainfall. Again, it shows you can see low to high rainfall coverage here. Fine, and it's very common sense. जहाँ पे high hilly areas होते हैं वहाँ पे rains आता है, isn't it? So you have these are the areas where you have high rains. These are small pockets where you have average low to high के बीच में rains urban area में हो. Again, that's a concerning factor. Okay. Now the next step is collecting the data. So you have to collect the data sets find from where they are available. Now, if you say satellite data, तो वो दूसरा source है. You say GPS data, that's a different source. Fine. And again, if you say software part, that's again a different source. GIS में काम करना तो GIS software आपको RGIS लेना है, आपको image processing करना है तो ADAS लेना है या any other software which is open source or which I have to purchase. You have to plan for it. Right? So this is the data sets and the technologies that you require. You have to review it. You have to do some initial surveys or interviews to understand the nature. Like here again, coming back to my student's problem when he said कि ये river के वजह से, then I had to ask him some questions then. So if I have to ask him, he is the only representative for me for that city, but I cannot rely only on his answers. So I prepared a questionnaire, right? And I told him कि न्यू पनवेल सिटी में अक्रॉस द रिवर में जहां जहां जो बिल्डिंग्स है यहाँ पे ये क्वेश्चनर जाके भर के लेके, फाइन, फ्रॉम एजुकेटेड पर्संस ओवर देयर, फाइन, स्टेइंग देयर. So from what time to what time they have the smell there, fine, what period, fine, throughout the year they have or only certain time period they have. So all this questionnaire I had prepared because this will give me an exact thing which thing I have to apply कि ये उनके जो findings है, उनके जो they are suffering उसके आसपास जा रहे हैं. Okay, so this is the thing I have to work out. So you have to consider vulnerability factors, class and hazard factors. So these are different maps that they have prepared based on the hazard factors and the vulnerability factors that they have considered. So here it is, you can see these are the vulnerability factors map. Okay, so you have population density, you have dwelling quality, that is what type of buildings they are. You have household incomes, distance to cultural heritages, distance to medical centers and hospitals, and this is the complete land use which gives you the bifurcation of these areas. Similarly, when it comes to flood hazard factors, you have elevation, slope, directions, that is aspect rainfall data. I've just shown you distance to drainage, distance to urban drainage density, soil hydrologic group, very important because I should know even the soil type, whether it will percolate that water or it will go as runoff. Fine, precipitation runoff जैसे जा रहा है या percolate होने का वो soil का chances है. Fine, okay, so that I have to work out. So all these vulnerability factors I have mapped. Why? Because I have to combine these two to get the risk. Fine. So at the end, like here, as sir said, AFP model they have used because it's a very popular model. It goes by pixel values. Pixel values means क्या? ये जो data है, population data and all what I have got it, isn't it? It will be available in pockets, small pockets. So that complete city they have divided into say 1 kilometer by 1 kilometer or 0.5 kilometers by 0.5 kilometers, whatever grid you want. You divide that complete area into that grids. और हर एक grid में मुझे क्या value मिलता है? That you have to put it. Got it? So how these maps are prepared? Complete वो राष्ट्र city को मैंने grid में डाल दी. Fine. That grid का resolution is completely on you. You can even go for 1 meter by 1 meter. Fine. अभी 1 kilometer by 1 kilometer suppose, तो उसमें population density कितनी है? What is the population? Every grid I cover it and I put that values in that pixels, fine, in that grid, and I put this AHP model. What this AHP model does? What all vulnerability indicators I have put up here? Fine, population density, then the household income and all these indicators के लिए they will apply this formula there based on the weightages, fine, and work out a flood vulnerability value for that index. सभी population density का weightage डाल दिया, household income का weightage डाल दिया एक ग्रिड के लिए. तो ये सब कुछ combine करके I have a flood vulnerability in value for that one grid, and then I prepare a complete flood vulnerability. Okay, so this is what AHP does. What this AHP helps us? AHP helps us to give the weightages and work out or support the decision making. How it supports the decision making? क्या करता है ये? What is your outcome? You have to prepare for a flood vulnerability. Flood vulnerability indicators क्या है? Population density and all criteria you have. Every criteria you give a weightage. Fine. Considering which criteria is very important for you. Okay. Now for this flood thing, which criteria will be very important for me? Population density. Again, as I said, अगर population है ही नहीं, वहाँ पे कोई नहीं रहता तो flood का कुछ इफेक्ट रिस्क है ही नहीं. So the first criteria that I'm having is the population density. तो मुझे वेटेज कितने देना है उसके ज्यादा है. So based on this is what these are the factors investigated, and based on this is what the values are. So you can see population density, a high weightage is given. This you can do on your own, or if you have expertise into it, you come to know, this can be the value. Okay, so this is also called as blind weightage. Blind weightage mostly is done by your experience. Fine, you stay in this area, you know what is affecting most. Fine, which indicator is affecting most, or which indicator is very important. So accordingly, you give your values to it. Fine, so you give the weightage so that the complete summation comes to 1, and then based on this, you create the flood vulnerability. Now, when it comes to hazard model, where you have this all the ground parameters, elevation, slope, direction, rainfall, all these ground parameters. Fine, when you have to put it, you have to model it. Got it? Here we can do the predictive modeling. Yeah. So यहाँ पे predictive modeling या model करना भी है. So which can be involved, the models can be the one. These are all popular models that we can use for hazard modeling. Very popular models used and defined. Okay. So even here the researchers have used all these models. Fine. The full forms are given you only. Out of this, अगर कुछ भी नहीं आ रहा है आपको मॉडल कौन सा एग्जैक्ट कौन सा यूज करना है, लेकिन मुझे एक ही मॉडल यूज करना है, मुझे आई कैन नॉट गो विद ऑल दिस मॉडलिंग डन, यू कैन बेस्ट स्टार्ट फ्रॉम रैंडम फॉरेस्ट मॉडल, बेस्ट एमएल machine learning pattern. Okay, supervised, like you have the complete control, that is called a supervised. Okay, so you apply that, and for this, how to apply, you have different softwares and all. Here in this research, the researcher has used this modeling package in R. And you can use MATLAB and all this. Okay, so you got to know now, this is complete different modeling here when it comes to non-spatial parameters. Population, isn't, these are all non-spatial parameters. These are spatial parameters. इसको location है हर एक चीज को. Fine. So spatial parameters का modeling, you always have this type of things. And non-spatial modeling, you can use AHP, you can use all your other statistical modelings also. Yeah. Okay. So once you do this, final part is methodology to adopt and take out your results. Fine. So the steps here is select suitable techniques that you want to, design the workflow, and then take out the results, validate. Fine. So here the validation is done. See here, this is the complete workflow. What outcome you want is urban flood map. What you do is you prepare a data set. Fine. That is hazard modeling table. Fine. What data set you have? You have Landsat data, satellite data. Fine. You have Landsat data, or you have any other sentinel data. Fine. So you take that and you make a partition of वो data जो है, fine, which is in pixels, grids में available. ये complete pixel को आपको क्या करना है? Split करना है. And how? You are going to use 70% of the data training, that is supervised, I say, and here 30% you will use for validation. Fine. Like those who are not knowing about it, this is called as image processing techniques. Here what we do is, say for example, आपके पास एक ऐसा image है, वो image pixelated होता है. Fine. अभी ये image को आपको classify करना है, map बनाना है. So what you will do? ये image को left to right आप जाओगे, grids को, and every grid what information it is. You will take this. Fine. And 70% of these grids you will train कि हर एक grid में क्या-क्या value है. Fine. So हर एक grid में what you say, one grid you have a water body, one grid you have vegetation, one grid you have a residential area. So ऐसे सब कुछ अपना वो 70% data को train करते हो, samples ले, random sample. Fine. Here it is settlement, here it is water body, here it is vegetation. Fine. You have declared supervised because you know the ground truth. Yes, I know यहाँ पे residential है. I know यहाँ पे water body. You know. Pardon? Yes, you can use air and also. Fine. Here it's done simple. All the modelings that are there, they do the same thing. Fine. So 70% of that grid, that pixels, you yourself have with the ground truth, you have classified it as ये इतना है, ये इतना है. Okay. And then what you do? 30% random. All this is random. 30% जो grids आपने नहीं check किए हैं, उसको आप ये मॉडल डाल देती हूँ जिसने आपने क्लासीफाई किया है, ये ग्रेड में ये है, ये मॉडल को 30% में डाल देते हो और ये 30% का जो ये है ग्रिड्स है वो ये मॉडल को अप्लाई करके खुद बता देता है। अच्छा मेरे पिक्सल में वाटर बॉडी है, मेरे पिक्सल में वेजिटेशन। नाउ व्हाट यू हैव टू डू दैट, ये 30% जो एमएलएम ने किया है यू आर गोइंग टू वैलिडेट विद द ग्राउंड रूट। अच्छा इसने वेजिटेशन बोला, यहाँ पे वेजिटेशन, दैट मींस माय मॉडल इज वर्किंग फाइन। क्लियर? अच्छा इसमें वेजिटेशन बोला बट इट इज सेइंग 50% वेजिटेशन, एक्चुअली इट इज 80% वेजिटेशन, थोड़ा सा एक्यूरेसी में कर दो। व्हाट इज दिस इज हाउ द एमएलएम, वेरी सिंपल टू सी। अभी इसमें कोडिंग है, व्हाटएवर द एल्गोरिथम्स एंड ऑल दे आर ऑल अवेलेबल फ्री, so you don't even have to write the codes for it, it's available. Okay, so our software you have this random forest MLM. Even if you don't have R, Google Earth engine में खुद वहाँ पे random forest के scripts है, algorithms है, you have to directly put it there. Fine, okay. So you what it is done here, you can see ये सब partitioning किया, इसको ये सब modeling लगा. Fine, all these models they are applied. Fine. Once it is tested with it, what it is applied, these are the parameters. Fine, that is trained. Got it? Heat, rainfall, soil, hydrology group, ये parameters इसमें डाल के train कर दिया, validate किया, and then model का selection किया, model का validation किया. Fine. From this validated data, the model is validated. Now, once this model is validated, okay, how we say model is validated? Area under the curve, which is greater than 80%, जिस model का area under the curve greater than 80% आता है, AUC greater than 80% आता है, that model I'm going to use. Fine, okay. So this is how the model fixation here, hazard modeling is done. Vulnerability factors you have already done with the EHP. You have done the weighted overlay analysis. Put all this over here. Put this flood hazard modeling here. It will just multiply both these things, and what you get is your urban plans. Got it? So you have complete parameters identified. You have worked on that parameters, how to scale it, how to work out on that. Now what you have this workflow. यहाँ पे hazard maps होंगे, यहाँ पे vulnerability maps होंगे with all these indicators. And to just come on, fine, okay, and then you have to just check out the results. Result validation and accuracy. So any geospatial technology tools you take, at the end you have to validate the results because it is real world scenario. Fine, you cannot just hypothetically say anything. So here what we do, we apply the performance evaluation matrices.
Is it necessary to identify R-square?
No.
No.
R-square is very basic.
So A to E, right?
AUC.
AUC rather than 80%.
AUC itself is a validation model.
Okay, itself is a valid.
AUC is itself a validation model.
Okay.
It will tell you whether my model is working right. R-square and all statistical regression and all, it's now very basic thing.
Okay.
Fine. Like if I want to work out the NDVI, normal differential vegetation index, तो वो NDVI का R-square क्या है? It's simple. I can work out. But when I have to do this hazard modeling and all, then you have to have this performance evaluation matrix. So where it is, yes.
That area under curve should be greater than 80%. So 80% is a assumed percent.
The model says that when the model is working, giving you results more than 80%, that means it is a validated.
For that particular one.
Yeah, for that particular one. Yes, it can vary. But 80% उससे ज़्यादा है तो वो model accurate है. You can rely on it.
It's validated.
Yes.
How do you consider the runoff data status for this?
So you have to calculate the run.
It is going to be changed.
Yes, it will change. It will change based on how much amount of rainfall you have. You will have daily rainfall runoff different. You can have, annual runoff different.
But the type of the soil is also.
Yes, that is what. That's why we have taken this parameter. Like when you have the agricultural area, there the runoff and the percolation will be different. So soil hydrology is how much amount of water the soil can contain or will allow to pass through.
Second, the water table. Can it impact?
Of course, definitely. That's why soil hydrology means soil में पानी पहले कितना है, ऊपर से आए तो पानी कितना ले सकता है, pass on कर सकता है, is what soil hydrology tells you all. So if your soil is permeable, and if you allow the water to go through, so you have different soil, characteristics. Like I can say A, B, C type of soil. So one soil like clay soils, it doesn't allow us to percolate, fine, but it will have a runoff. Okay, but even if it is having runoff, it will not be like soil will be eroded with the runoff. But if you have sandy, silty soil, soil also gets eroded with the runoff, isn't it? And then it is collected in the river books. So that thing, soil hydrology parameters.
That is including groundwater potential zone also. If renewables and the
Yes, yes, yes. Yes, we can do that.
same as it is for a rainfall.
Yes.
Why we take it as?
You have some equations, you have to work out that, then you can work out the, what you say, the groundwater table existing, what it is, and then what can be the potential to hold the water inside. So can I complete this? This part. So now here what we have, this matrices you have to compare, you have to, work out on that model, you have to calculate. What it means, H means hits. How much number of hits you have given. Right? The model, how it is applicable, how many times you are applying and how much, what are pixels. It is actually hitting properly. Right? So H is hits, CN is correct negatives. Like it's wrong and the model also tells you it's wrong. Right? And then FA is false alarms. Like this is the thing and model tells something different. Okay? And M is the misses. Like the model is not taking only that pixel. Clear? So in that complete pixel x by x or whatever you have this numbers. Fine. Once you have these numbers, put it in these equations, get out the accuracy, probability of detection, false alarm ratio, precision, and AUs. Okay. Once you get this, you work out for all the models. Prepare the tabular chart. Now here from the tabular chart itself, you can see all these values are high for this card model. Right? Okay. In this sequence only it is arranged, so that we come to know, yes, this is the model which is giving training data set ke liye bhi value and training validation ke liye bhi it is giving value. This is the AOC for the validation. Fine. Okay. So what from this result I can make it out, card model is very proper fit for the. Okay. So these are the modelings done by different methods, card, random forest and all. So from here, not only you get your accuracies, you also get how much area is at risk. Fine. So here it is say kilometer square at what all levels of risk you have. So we can say all the figures is giving 95 kilometers square risk analysis. Fine. But area when it comes under very high risk for card model, it is giving higher values than as compared to what we have the other models. Fine. So card model we apply to the hazard model, vulnerability to change hone wala nahi, we have the data with this, we apply to this and we get our risk. So AHP, vulnerability, hazard map card model, apply it and get your final risk. Fine. Okay. So the vulnerability classes, this is the vulnerability map, where again the classes were divided into, this is the qualitative marking. Fine. आपको maps दिए जाएंगे which a layman can understand in this language. I know and all. But if I want to know the area and all, I can work out over here. Fine. These are the 5 classes. This is the urban risk map. Again with these levels, that is again classified into very high to low. Okay. And the area that I put. So if I give this type of map to any person staying here, I can understand it. Right? But what has happened behind it is what we can only understand. Got it? So this is how a problem formulation to the outcome that you want, and that should be very much applicable or very much going with the real world scenario. Right? So here we will stop, and then this is what at the end we do. We have this real world, fine, and we want the output that we have predicted, we have considered it, and we are presenting it. In between, what we have is the raw data, and we have to do the modeling. That is a manipulation on modeling. What goes here is what we are learning: geospatial data or geomaps. And whatever we do is applicable in this raw data or in this data model. Right?
From AHP techniques, we decide different criteria, right?
Yes.
So different weights are given to it.
Yes.
So that weight percentage from scale 0 to 10, what we means how we can decide it? Whether it's from previous literature or there is any standard method or equation something?
There are two. One is the blind weightage and the other is based on the statistical studies.
Okay.
Fine. For statistical studies, you have to have lot of data. Say for example, मुझे अगर यहाँ पे population density के लिए करना है तो मुझे census data चाहिए. Fine, growth rate चाहिए. Then I can say कि population के लिए कितना weightage देना है. So similar, all of the parameters, I have to have the data with me. I'll do the statistical calculations based on that. I consider this is what the important parameter is. इसको ज़्यादा weight. That is calculated, statistical. The other is blind weightage, that is by experience. Okay, so for example, when I prepared vulnerability map for Mumbai city for transportation sector, so I made it, complete 12 hours. I divided it into two hours. Fine. So 2 hours के लिए मैंने weightage दिया. So I know 6 to 8, morning 6 to 8. What should be the weightage? That is the transportation sector will be used. Railways कितना use होगा, street कितने, roads कितने use होंगे, fine. So being I am born and brought up over here, so I know that. So I know कि 6 to 8 में 0.7 होगा, but 8 to 10 it will be 1. क्योंकि trains भी busy होते हैं, road भी उतने ही traffic होता है, so it will be 1. Again, it will be in the afternoon sector, it will be so a little bit reduced, but never it will be 0, never ever it will be even 0.5, more than 0.5 only. Based on the population, based on the running. Fine. Every 6 minutes train is running. Fine. So based on that, that is called blind. But for that, you require experience. You have to have the expertise to do it. So based on that, or else you have to go with the data. So here we will finish it off. So next we'll start with this geospatial technologies, how to do the problem, like how to use it next. So, complete conscious.
Make back after 10 minutes. Short break of 10 minutes. Short break of 10 minutes. Will be receiving back after 10 minutes.
I'll be a little bit quick here now because case studies are more and we have, I'm told, updated till 1 o'clock. So when I talk about geomatics and geospatial technologies, many a times people get confused about geomatics, geospatial, same thing, okay? Or what is the difference between them? So many times I saw seen this and many times just randomly within the research papers they put using geomatics technology or using geospatial technologies. So let me clear this. These two are different areas. Now they are little bit overlap. So when it comes to geomatics technology, we have geodesy, mathematics, and engineering. So what is geodesy? Geodesy is study of the earth science. Okay, study of earth. Okay, geo is earth and desy is study. So study of earth is geodesy. So we need to study, something about earth. We have to study about it to know what geospatial technology is really about. Otherwise, geospatial technologies, especially when I talk about GIS, is nothing but information systems that day to day we use it. Isn't it? We have to book a ticket. We have to book anything or purchase anything on Amazon. We have to track it. Right? What we do is information systems. Doesn't it? Is it into geospatial? And geodesy is what it makes it geospatial. So what is geodesy? Study of what we have to study of Earth? We have to study how the Earth is projected into 2D from 3D. Because what we do finally in GIS or the outcome of any geospatial technology is maps. Isn't it? And maps is 2D presentation. 2D representation है तो 2D कैसे लेते हैं? मतलब वैसे कैसे भी randomly करेंगे क्या तो no. So how this Earth is mathematically converted into a mathematical figure? Because we know Earth is completely irregular. Earth is not complete exact sphere. Earth is not exact elliptical. It is very random. You can say it's just like the shape of an egg. Egg is not complete exact elliptical. एक जगह narrow है, एक जगह bulge, isn't it? Fine. So can we have exact access to it or egg की जैसे ऐसे खड़ा नहीं एक symmetrical नहीं. It is horizontal. So the axis through which it is wobbling, fine. The equator, fine. And all this again, egg का तो curve smooth है, but Earth is not smooth. It is irregular from high peaks to ocean bed we have, fine. So this complete irregularity, that is geodesy, we have to put into a mathematical figure. And once we put it into a mathematical figure, that figure we have to cut open to make it 2D. Right? So what we do in geodesy is very basic thing I'll tell you. It's complete a very different field altogether. Fine. So earth sciences, geology, and all that people have to study. But if you have to study geospatial technologies, or you want to know about the satellite data, how what it gives, what imagery it gives, or UPS data कैसे use कर सकते हैं, coordinates कैसे करते हैं, so you have to know geodesy. Otherwise, you cannot use these geospatial technologies for that purpose. Fine. So what happens is, once you have this irregular Earth into a mathematical model, you put this model into a cylinder. Fine. So for example, ये पूरे अर्थ को irregular surface को हमने ellipse में elliptical इसमें डाल दिया. Okay. Now ये ellipse जो है ये मुझे एक cylinder में डालना है या फिर एक cone में डालना है. Fine. Okay. And when I put it into a cylinder, that one line of that elliptical figure will touch the cylinder surface. Right? Okay. Now, there when I cut that cylinder and open it, it becomes 2D. When I put that figure into a cone में भी वो कहीं पे तो touch करेगा. Second, fine. I can have 1 second or it can touch 2 times. So you can have 2 seconds, fine. And then I cut open along it and I get it 2D. This is how maps are done. Fine. Okay. So ये कट कैसे करना है, कहाँ पे कट करके ओपन करना है, सिलेंडर कैसे खड़ा करना है, एलिप्स ऐसे खड़े में डालना है, इस सिलेंडर को ट्रांसफर करके एलिप्स डालना है. All this is geodesy. And this what we do, that is in a 2D that we open it, fine, we call it as projections. Okay, so we have cylindrical projections, we have conical projections, we have planar projections. क्योंकि क्या होता है ये ellipse, fine, like you put it into a cylinder. and you're going to cut open. Fine. तो क्या करते हैं हर एक पॉइंट जो सिलेंडर जो एग पे है we are projecting it on the cylindrical surface. Fine. For example, this egg is having small holes in it, and you have a cylinder. वो सिलेंडर में वो एग डाल दिया, नीचे से बल्ब फ्लू किया, तो वो जहां जहां होल्स है प्रोजेक्शन कहाँ पे आएंगे, सिलेंडर पे आएंगे. Fine. And you cut open, you get your solution. Right. But then these maps are again, you know, exact नहीं होंगे, वो exact point पे नहीं आएंगे. Fine. जहाँ पे टच हो रहा है वहां पे एग्जैक्ट आएंगे, जहाँ पे टच नहीं हो रहा है वहां पे तो नहीं जाएंगे. जैसे पोल्स किया, पोल्स के पॉइंट सिलेंडर पे कैसे आएंगे, कैन नॉट कम. राइट. सो देन दिस रिसर्चर्स और दिस मैथमेटिशियंस और वी कॉल इट एज साइंटिस्ट, दे हैव यू नो इन्वेंटेड दिस डिफरेंट प्रोजेक्शन considering their countries. So then we have planar projections. Planar means क्या, ये egg जो है उसके poles पे पेपर डाल and project the whole areas, fine, and down. So what happens because of this is origin gets shifted. Origin shift होता है ना, हर एक का origin अलग होगा. सिलेंडर में तो origin अलग होगा, 2D का ओपन करने के बाद मैप, होल है तो origin अलग होगा. This is how in college, sorry, in schools we have studied about prime meridian, Greenwich meridian, and equator. Equator is the line which actually touches that mathematical, you know, the object that is cylinder or poles. जो टच करता है वो हम लोग बोलते हैं इक्वेटर. Fine. तो फिर वर्टिकल में क्या करना है, तो वर्टिकल since this what do you say, this concept of projection and all this was developed by, at that time the Europeans, they developed it and had put it first. Fine, that is Mercator. He had put it up first. So he said because the Greenwich meridian passes through their area, they said Greenwich meridian is the primary. They made it as 0. Not necessarily it should. बाकी के लिए क्या scientist, right? But then that was the concept because they were dominating the world at that time. They made it all, and we have studied that in the college. But when it comes to right now, the softwares that we work and the spatial projections that we want to deal with the research is completely different. So when you're talking about India and you want to have India only, fine, India के ही coordinates चाहिए आपको, बाकी वर्ल्ड से कुछ लेना देना नहीं है. So what you will do, you will have your origin that is 0 of your coordinates somewhere in India only. It should be there, right? So Indian scientists, fine, long before we had our prime meridian which was passing through Madhya Pradesh. Fine. Madhya Pradesh se pass hota hai, and you must be knowing Mahakal, isn't it? There was where we had the origin 0 of India. Okay. So now when I want to talk work for India, I work with that projection. Why have to work with that European projection? Because when I work with European projection, India का distorted होता है. फिर वो डिस्टॉर्टेड को वापस लेके आने के लिए मुझे वो n कैलकुलेट करना है. व्हाट इज द सेपरेशन थिंग टू मेक इट बैक. सो कितना टीडीएस है, इंस्टेड आई कैन वर्क विद माय ओन थिंग. So here this is how we have projections. So when it comes to GIS, when we work on only for India, we can go for our projection that is called as projected projections, geographic projections are what we have for India. You can go for Everest India, okay, ellipse. 1980 में ये ellipsoid डिजाइन किया था इंडियन मैथमेटिशियंस ने. तो दिस ellipsoid, how it is designed, you know, ellipsoid का जो कर्व है वो एग्जैक्ट इंडिया के साथ मैच होता है. ellipsoid का जो सरफेस है ना वो एग्जैक्ट इंडिया के साथ मैच होता है, और वो ellipsoid कॉनिकल प्रोजेक्शन में डाल देते हैं और कट ओपन करते हैं. दैट इज हाउ सर्वे ऑफ इंडिया हैज प्रिपेयर्ड इंडियन. Now this India के map, Survey of India, at that time Reshma only has prepared it, fine, and Sir George Navis has prepared it, fine, and hence we had named the mountain number. If इतना इंडिया के लिए काम किया तो दे दे, fine. But and that is how we have this Indian Everest ellipsoid, which the origin it is in Kalyanpur, Madhya Pradesh, and from there are coordinates, and these coordinates are not, you know, degree minute seconds, they are Cartesian coordinates in meters. Fine. So this is how, you know, very large depth studies you have, lots of thousands of projections you have. Fine. You have to select exact projection of how detailing work you want to project it out, how detailing work you require. Fine. This is one concept where you have the geodesy. So this comes into What happened here?
This is.
So,
Located at
Stand by our bill.
we have thousands of ellipses. Long before जो पहले किया है वो कल्याणपुर में जो सर्च जॉर्ज एवरेस्ट की के साथ हुआ है and Indian Everest ellipsoid. Now after that when other mathematicians have worked they have put up Nagpur is the origin but we follow geospatial में जो projection follow होता है वो Indian Everest ellipsoid और नागपुर का projection है नागपुर के projection local projection भी कॉल ग्लोबल में इंडिया को प्रोजेक्ट करना है इट विल बी इंडिया that is all we have thousands of projections what all scientists have done so this is the first thing which we want to know कि क्या projection लेना है मुझे right again that's another matter which again all the people have come together and solved it like what we have UN isn't it United Nations सभी countries के लिए साथ में कुछ decision लेता है वैसे geospatial में भी we have all the things coming together कि बाबा ये सब कुछ problem हो रहा है everyone is following their own thing and in US when I want to sit and want to open India का data and in US projections NAD 83 and all India to distort होता है what I can do so then what we do is we have a global projection that is worldwide accepted which we call it as WGS 84 World Geodetic System in 1984 what they did is this complete earth isn't it they made it into one ellipsoid mathematical ellipse how कि अर्थ का जो सेंटर ऑफ मास है वो एलिप्सॉइड के सेंटर से मैच उसके पहले जो 1000 एलिप्सॉइड है से जैसे इंडियन एवरेस्ट एलिप्सॉइड है उसका सेंटर अर्थ के सेंटर से मैच नहीं होगा लेकिन एलिप्स का सरफेस इंडिया के सरफेस से मैच सो एलिप्सॉइड विल बी गोइंग एनीवेयर इंडिया का मतलब अर्थ ऐसे है इंडिया यहाँ पे है तो एलिप्सॉइड वहां से शुरू होकर ऐसे जाए लेकिन सेंटर अलग हो that will be thousands of ellipses they are called as local ellipse projections But if you want to go everything as a common, कि मैं कहाँ पे भी बैठूं कहाँ का भी एरिया मुझे एक डेटा में ओपन करना है प्रोजेक्शन में, I can go for World Geodetic System 1980. Fine. This ellipsoid center of mass is center of the ellipsoid is center of mass. Fine. So the axis matches. Fine. And what we have is the coordinates which are everywhere globally accepted. थोड़ा सा distort. अगर मैं इंडिया के लोकल प्रोजेक्शन से ले लूं और WGS ATM से ले लूं तो डिफरेंस ज्यादा नहीं and that difference remains fixed okay now again this WGS 84 is continuously updated that is another thing क्यों क्योंकि एक्सिस tilted है अर्थ का and this axis also wobbles because of the gravitational pull FPG प्रोजेक्ट जो होता है उसकी वजह से जो अर्थ मूव होता है उसकी वजह से एक्सिस भी सेम नहीं रहता it wobbles and if it wobbles the frame will not remain fixed right और frame नहीं रहेगा तो coordinates कैसे रहेंगे that is why GPS okay global positioning system gives us this geoid which I say ना कि common ellipsoid है उसे बोलते हैं हम geoid अभी common ellipsoid कैसे निकाला है how this ellipsoid is worked out what we take it as mean sea level right so we work out the mean sea levels and we join that we call this mean sea level का curve that irregular से थोड़ा like कम आएगा that we call it as mean sea level का curve that is geoid okay और ये geoid को mathematical ellipsoid भी easy है डालने के लिए I getting it complete irregular है उससे मैंने mean sea level जहां sea level के points हैं that I mark मुझे थोड़ा सा curve मिलेगा okay irregular लेकिन curve के इसमें थोड़ा सा मिलेगा उसको मैं mathematical exact ellipsoid में डाल दूंगा and that ellipsoid I put it in any projection. This is how the geodesy works. And in addition to this, we have continuously updation of this gravitational pulls, axis wobbling, how much it is eccentricity it is having, and based on this, every coordinate keeps on changing. So, what coordinate you have for your location now? After 1 or 2 days, it will be different because there's something different going with the Earth. And it's all relative. So that is what I always say. कि अर्थ ही यहाँ पे फिक्स नहीं है तो हम लोग अर्थ पे कहाँ फिक्स है हम लोग कितना हम लोग के लिए करते हैं हम लोग को ये चाहिए सब फिक्स चाहिए nothing is fixed isn't it so this is how geodesy goes into this and then what we have is this so we have this geospatial technology so what happens in geospatial technology we have geographical analysis which we do all this through the satellite data fine and we put our information science, whatever the model is, what we have, isn't it, into it, or the non-spatial information that we have. For example, location है यहाँ का class का, लेकिन ये class का नाम क्या है, कुछ और है, that is non-spatial information connected to the spatial. So all this I have with this information science, put it, and what I have is geoinformatics. Fine. So geoinformatics with base of geomatics is what you apply for any problem domain and you get your solution. Fine. So when I say accuracy, precision, near to the world, results when you want to have, you have to study this or you want to know this in it before you apply this. Okay. Now, when I say spatial analysis, what we do, we analyze the information, fine, and this information analysis, what we do, either we do the computations or we do the visualization or we do combination. So, अभी मैंने जो एक case study बताया, problem formulation application, we have done the computations, hazard modeling, and what we did at the end is visualization, qualitative maps बना, that is visual, isn't it? अगर मैंने आपको पूरा लोकेशन वाइज ये कोऑर्डिनेट और ये लिस्ट है, will you be familiar with it? Will you be, easily accepting it? You will not know anything. But when I put it in the map form, which you are, very easily connected to, isn't it? That becomes easy. So visualization is what a key factor for geography technologies. Where is the software? It has nothing to do with satellite data at all, but it's the software part when you use this extracted data and convert it into a visualization form. So remote sensing technology, actually when we talk about, this is ground-based, air-based or space-based. So ground-based, initially we had, aerial photogrammetry, where we used to take photographs, and with the photographs we used to do some measurements. That is called as aerial photogrammetry. Nowadays it's not used because aircraft planning, flight planning and all we had to do. Again, there were not many issues in that क्योंकि weather anything नहीं है. Time to time frequent data मिलेगा नहीं aerial photogrammetry से क्योंकि flight के हमेशा aircraft हम लोग भेजेंगे नहीं. Right? So that were some issues. But nowadays what we have is drones, fine. And drones initially were with the cameras, high resolution cameras. Now they are with sensors. So you can have LiDAR, hyperspectral data also. Fine. Okay. So initially it was only optical. Fine. Then next we have airborne. Again, as I said, aerial photogrammetry. In very special case, for a smaller area, isn't it? And for a long term, when you have to do the analysis and you want some data, you can go for aerial photogrammetry. Like IIT Bombay, when they have to do, crop monitoring for a specific region and all, they go for aerial photogrammetry. Drone bhi chahte, but aerial photogrammetry because, initially they had all this data, them to analysis, to do the analysis and image processing and all. Okay, digital photographs. Then what we have is spaceborne. Spaceborne, we all know about it. We have the satellites, which are called as remote sensing satellites, which are placed at an altitude more than 38,000 kilometers. Okay, 38,000 kilometers के altitude पे ये satellites placed है, so that they are not obstructed by any other, what you say, troposphere and all. Fine, deals with that. Okay, so there they are placed and they are geostationary or they are polar orbit. Geostationary in the sense, if India is sending the remote sensing satellite, it will be over India continuously. So the movement, fine, in its orbit at 38,000 kilometers or more than that, it will be such that it will move as India moves. Fine. So 24/7 watching India, but it's not only watching India. It watches other areas. Now, having said that, it's not like it will be stationary there. Said that ऐसे नहीं होगा. India के ऊपर, पूरा India के ऊपर focus ऐसे. No, it will keep on scanning India and next in the neighboring areas of it. ऐसे scan होता. So this is across track scan. Okay, and then some satellites are placed उतनी ही belt में. Some satellites are placed this push mode. Okay, push mode scan ऐसे भी. So very different types of satellites that are, put up. So क्या कैसे satellite का scanning कैसे करने वाले हैं? That is completely designed by the ISRO. Okay. Now here when you put the satellites, that satellites will have array of detectors, sensors into it. Fine. एक ही कैमरा नहीं होता है, एक ही स्कैनर नहीं होता है, ऐसे छोटे array of scanners होते हैं. Fine. So every sensor will have a small swag. Okay? ये सैटेलाइट है, इसके ऊपर इतने सारे स्कैनर्स हैं, हर एक स्कैनर का फोकस ग्राउंड पे जब आता है, फाइन, ओके, ऐसे है। तो हर एक स्कैनर का जो ग्राउंड पे स्वैप है, दैट इज वी कॉल इट एज स्पेशियल रिजोल्यूशन। तो हम लोग को सैटेलाइट डेटा मिला तो वी आस्क फर्स्ट थिंग इज वी आस्क व्हाट इज द स्पेशियल रिजोल्यूशन, फाइन। सो अ सैटेलाइट वी हैव अ स्पेशियल रिजोल्यूशन ऑफ 30 मीटर्स का 30 मीटर, दैट मींस उसका एक जो स्कैनर है, फाइन, इट स्कैन्स that swap on the earth of 30 meter by 30 meter at a time. और ऐसे 50-100 स्कैनर्स हैं, तो ऐसे स्कैन करते जाएंगे। अभी 50-100 स्कैनर्स क्यों? Because one scanner will scan it in one way. Remote sensing completely works on EMR, electromagnetic radiation. क्या स्कैन कर रहा है? Electromagnetic radiation. Reflectance जो आता है, isn't it? By the earth surface, it scans that reflectance. Algorithm. Okay. The beauty of this nature is every object on the Earth's surface is having a different reflectance, which we call it as spectral reflectance. Okay. Human body is having a different reflectance. Fine. Trees are having a different reflectance. Not only this, trees different age का है, उसका different reflectance होता है. So, based on this, spectral reflectance properties is what we scan what that element is. So, in the previous thing I told you, यहाँ पे vegetation है, यहाँ पे water body है, यहाँ पे settlement है, कैसे scan करता है? उसके reflectance को लेके, अच्छा this is settlement, इसका reflectance vegetation cover में, that we have complete curves, ready-made, जैसे हमें RS codes होते हैं, वैसे इसके curves ready-made है. If this is the spectral reflectance, this will be the vegetation. Water body का spectral reflectance इतना है. All these reflectance captured by the satellite sensors, that sensors can be in near infrared or can be in visible band or can be in thermal band. So thermal band में है तो वो heat में scan करे, thermal wavelength can scan करे. If you have visible band, which is our human eye, the band range, isn't it? So everything will be scanned in red, green, and blue, right? And the mixture of it, what we have, is what we get our features. So when we see trees as green, because it absorbs blue and red and reflects green, and how we see it as green. Actually, green है कि नहीं वो पता नहीं हम लोग को, लेकिन हम लोग को आंखों को दिखता है. So dog may see it as different, a cat may see it as a different, fine. But we see it because we have only that 0.4 to 0.7 micrometers का ही range है हमारा. और सब कुछ हम रेड ग्रीन ब्लू के कॉम्बिनेशन में सबट्रैक्टिव एंड एडिटिव में लिखते हैं, isn't it? So we see oceans as blue because it observes red and green. That's the reason signals are red, because red का wavelength जो है ना, isn't it? Shorter wavelength, long time के लिए it can be seen. That's why we have the signals as red. Fine. So based on this is what this remote sensing, these sensors are placed. हर एक स्कैनर का अलग अलग बैंड के लिए स्कैन का डिजाइन होता है. So when it is scanning, first one is red, second one is green, next one is blue. Again उसमें भी छोटे छोटे parts में I will divide it. So it will go on scanning each thing in a different band. So this complete one tile will be scanned in the red band, green band, blue band. Fine. Now when I process it, what data I require? I want vegetation. So मुझे किससे importance है green में? I don't want red and blue band, is it? So I'll focus only on the green band. Here, this is how the processing is. Very common way I am telling you, but when it comes to the science behind it, the studies behind it, it's long. So this way we scan all this data and we get it. Okay. This is what it happens, as I told you, the wavelengths, the reflectance. Fine. So concrete will have a different reflectance. Bitumen will have a different reflectance. You can exactly map where you have the highways, where you have the roads, bituminous roads. Fine. You can differentiate. Now comes the GPS. Fine. How GPS works? GPS satellites are placed at an altitude of 20,000 kilometers, lesser than the remote sensing satellite. Now, when you have to scan the the area, given areas in India with the remote sensing satellite, we require only one satellite. Maybe with that, array of detectors into kitna stack complete karna. But when it comes to GPS, we have to have at least 3 satellites, right? And these satellites, it captures signals. It doesn't capture images. It captures signals. कौन से signals? Radio signals. Okay? Radio signals, microwave signals captured. So what it does, it will have a transmitter at the satellite level. It will have a receiver in your receiver, the receiver. Okay, that is your mobile or maybe a GPS system. Right? So what it does, the signal that is thrown from the satellite, it receives that signal. Fine. Okay. Now when it is receiving it, when it is thrown and it is being captured there on the earth, transmitting time and the receiving time is recorded. Who records it? Control station. Fine. So what it happens? Transmitting signal and receiving signal. Will it receiving signal time? Will it be same? Because 20,000 kilometers just over, so it is in the troposphere. Troposphere में there are lot many delays. Ions है, isn't it? Atmosphere है, तो signal delays होते हैं. So now with this signal delay, that is the noise, you remove it out, and you get the offset from the transmitting time and the receiving time. Time offset you get, isn't it? And the signal phase, you know, the strength of the signal, you know, isn't? You calculate the distance from the satellite to your receiver. Fine. So you're not even, and you have that with 3 satellites. And the satellite position in the space, you know, because we have put in the speed and all we have designed. So X, Y, Z, all the satellite in the space I know. Fine. And I have 3 satellites. So X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3. I know. Plus I know D1, D2, D3 from the 3 satellites to my receiver. So with these known parameters, I find out X, Y, Z of my receiver. This is how you are being tracked by your Google Maps. Because you have a GPS chip. Right? So time कौन सा है? Here what we have is the quad clock. Okay? अपने receivers में, GPS receivers में, mobile में भी जो है वो quad clock होता है. और satellites में atomic clock. So they don't have our calendar year and our data. 12, 12 p.m. and 11 a.m. No. They have universal time coordinate. And the quartz clock, that's the time that is there, the GPS chip gives, it is converted to UTC and the time difference is constant. Okay. Now having said that, कि GPS हम लोग को GPS के अलग receivers क्यों चाहिए? What you have in your GPS is for low strength. The signal that it captures, isn't it, is low strength signal. That is how the satellite is blocked. Satellite आपको low strength signal नहीं आपके mobile को दे. Then where is the high strength signal? High. क्या होता है? It is in receivers that are used by the military. Only that is kept open first. Okay. That's the reason what coordinates we get and what coordinates defense people we get will be completely different. Clear? Okay. This is how GPS works. And this remote sensing data, this GPS data, you put it into a software which we have prepared. Fine, for modeling, okay, put spatial models, put non-spatial models and all, and you create 3D, 2D layers of them. Fine, different layers, you combine it, you create 3Ds, you create animations, whatever you want. Fine, that is how GIS. You've got to know remote sensing, GPS and GPS. Fine, so remote sensing, again we have drones till satellite data. Fine, and GPS, what we have altogether, fine, from every time. Over our net, we have 3 receiver satellites seeing us continuously, fine, and your mobile capturing or they capturing your mobile data and you give the location. Fine. Well, what we have is, you know, we have at least 10 meters of offset. Like अगर आप Google Map पे डालोगे और आप track भी कर रहे हो तो आप 5 मीटर के आसपास होते हो आपके जो locations. You will not be exactly at the location. It will, the map will tell you that. Okay. So now after this, you know, geodesy, a little bit of remote sensing and all. Now I will tell you the Google Maps that you use in your mobiles. These Google Maps are cylindrical, transfer cylindrical projected maps. Fine. Put on WGS84 data. That is Mercator. Mercator ने ये create किया है तो Mercator, transverse Mercator बोलते हैं उसे. Transverse Mercator data पे है ये and WGS84 पे है and with the GPS data that is tracked by your mobile based on again how smart and mobile you are. Okay, the constant frequency, even in low frequency, there are different zones. So if you see iPhones, that's the reason why they are very costly because iPhone captures आपसे जो लो फ्रीक्वेंसी है उससे थोड़ा सा अच्छा कैप्चर करता है. Okay, fine. So this is all about thing, and yes, the maps that are created that you see is in GIS. So you use GIS then. So you're using GIS, you're using remote sensing, fine, and you're using GPS then. Okay. So integration, how this data is integrated? You can collect spatial data through drones and put your GPS coordinates into. Fine, you can do that data acquisition. When you have to process, you have to georeference the remote sensing images. See, remote sensing satellite images, it gives you only image. It is not going to give you location. वो फिर picture ही है जो हम लोग mobile से capture करते हैं. Your picture, your mobile also capture, image which is pixelated. Is it? That's the way how we purchase our mobile. Isn't it? So here also we have the remote sensing, but if you don't georeference it, that is pin it up with your earth coordinates, then it's only where you have this thing, whatever you have this spatial feature with this coordinate there. So how to georeference it? You have to know the coordinates. How you got know the coordinates using GPS. And then once you have this, again this satellite data, as I said, it is scanning every time. So बीच में बहुत सारे problems है. First and foremost problem is the cloud. And satellite cannot say na cloud ko photo lena, isn't it? So we have to first of all take images with low cloud coverage. Why? High cloud coverage है तो कितना भी आप processing करो निकलेंगे, लेकिन low cloud coverage है तो you can remove the noise. Fine? You can remove the noise, you can remove the errors into it. Fine? And many times it happens क्योंकि वो भी satellite है. See, when we take a picture, कभी-कभी हाथ हिलता है तो blur picture आता है. So same way satellite में भी कुछ तो हुआ तो कभी-कभी blur image आता है. So हम लोग निकाल लेंगे क्या? No, we can make it up. Isn't it? So we remove all this noise, you process it. That's what on the mobile also we do it. Isn't it? Filtering करते हैं. Isn't it? Adjust and filter. So what it does? It does image processing on. It removes whatever wrong thing you have done. Isn't it? And make it better. Right? So this is what we do in the pre-processing. Integration, you integrate remote sensing GPS data into GIS patterns. So you cannot integrate in any other software. AutoCAD लिया और AutoCAD में remote sensing का image लिया, you cannot do it because georeferencing you cannot do. Because AutoCAD cannot take GPS data. Compatible नहीं है. हाँ, AutoCAD के जो layers है, you can put it in GIS. So GIS is compatible to lot many formats. Fine. Raster format, that is satellite का data. Vector format, that is what you have calculated and put it into Excel. Excel भी ले लेता है GIS if you know the coordinates. Fine. Okay. So this is how it works out. The very important thing is georeferenced data you require. That is, you require your coordinates. Okay. And then analysis and interpretation. We have already done this. Fine. Do the spatial analysis. Combine this, spatial data with non-spatial data. Spatial data model with non-spatial data set is model. Combine it, isn't it? Make it better. Split it up. Find what you have and create as many layers. Combine or overlay as many layers what you want, isn't it? But at the same time, like the beauty is, इतना सब कुछ करने के बाद हमें जो चाहिए we make it out, but the data in its original form remain as it is. That is not risky. That is what the beauty of GIS. Like I search it on, what I can say is, I have a app where I go for flight booking. Fine. The same app ma'am is using it. तो मैंने flight booking कर दिया, मेरा वो track दिखता है, isn't it? I get the options. These are the flight, this is the time, arrival, departure, and all. I get it, fine, and I book it. But at the same time, she is also doing it, so it doesn't matter होता है कि मैंने किया change किया तो इस मैम को change देता है. She will see the original thing. That is how GIS works. So at a time, n number of people can use it, use the same data, and make their mixtures, but the data remain as it is. Right? Visualization, you create 3D models and all. Why? Because this helps for decision making. Fine. Because when it comes to providing this data to the stakeholders all are not knowing geospatial technology. Fine. But they know the maps. They can understand the maps. Fine. अभी Google Maps कोई भी use करता है driving के लिए. You use it because you know when they say take a right, the Google woman tells they know they are going to the right, isn't it? Fine. So many times जैसे कि क्या कुछ भी बताती है वहाँ पे तो रास्ता है ही नहीं, isn't it? So we are all aware about the maps. So visualization helps for this decision making for the stakeholders who are not knowing this geospatial, or who are not knowing this modeling anymore, but they know this maps well. Right? So these are the flow things, how this workflow can go from paper maps, from remote sensing to GIS, air photos to GIS, digital elevation models, anything goes into GIS. Fine. Sometimes you require processing, sometimes you require digitizing, sometimes you have to directly import it as it is. Fine. Yeah, so this is what you can do. So when it comes to research part, this is the outflow. You have your research approved, the problem approved, you collect the data, you do the analysis and provide the results. But in between, when you have the spatial technologies, fine, it works in all these domains. Like you want to get the approval, first search it for whatever data is accessible to you. मैं 10 साल के कर सकता हूँ, 20 साल का डेटा लेके कर सकता हूँ. You first use the spatial data, see what is available, fine, see the extent, derive your or design your scope and limitations, and go for the approval. Once you approve, then data collect. Again, in the data collection, you use this same tool, fine, same technologies. Once you analyze, you again use it for analysis, fine, modeling area. Once you have done it, once you get your reports, you can do the mapping and all, data maintenance, monitoring, fine. Long term it remains as it is. You can even update it. That is how we get our weather data. Fine. COVID के बाद हम लोग को maps मिल रहे थे. WHO ने दिए थे maps, which was telling us what was the mortality rate, what is the affected rate, infected rate, what is the recovery rate in your city, isn't it? We are getting all this data. What it was, WHO had prepared these maps using ArcGIS. AC was helping them. Fine. Not only this, when we are taking our vaccination, isn't it? COVID वगैरह हम लोग को app पे जाके we were putting our slot वगैरह we were booking it up. All nothing, everything was GIS. पूरे centers के coordinates and all everything was mapped. The data over there was put up. कितने injections, vaccines है, क्या है, fine. And the moment you book it up, you are getting the OTP, that is the transaction information system, and you are getting the details. Isn't it? So this is how the results mapping, production, data maintenance, you have a central data pool, you can have it, fine. So research doesn't stop you. You have done it for 10 years, your next one can do it in 20 years, take some more another parameters and updated parameters right now, maybe some spatial कुछ changes हो गए हैं, developments हो गए, तो next वाला वो developments डाल देगा. So now this is how corporation is using these things. Okay. So क्या हुआ time? Huh?
I wish to one.
110. I'll just cover up, I can say. I would like to go for my case study. वहाँ से नहीं जा सकती हूँ ना मैं. I'll go for my work. This is all, GIS used for different domains. I'll put this because I told you about this work in the more as I started my lecture that Patalganga River pollution thing and all we had to work on. And these results, with the signed thing campaign, the people over there, they ran a campaign where they provided this, results with the letter, and they took a sign campaign. Fine. All the people over there nearby, they signed this, showing all this result that we are having, and then they submitted it to FPCE. Fine. And FPCE then had assured them, yes, they will take a proper action. Okay. So what was it? So this work is produced, I can say displayed in this chapter book. It will be released in April 2025. Ebook will be released. Geospatial technologies for water quality monitoring. The thing what we did is data collection, data analysis, and then the technology integration. Okay, mapping, and then what we did is change detection. Change detection means over the period, fine, whatever period we have considered, what was the changes happening in that river stream for the given stretch. Okay. So this was the problem that we designed, that is impact of urbanization on nutrient loading and eutrophication in the Patalganga river. Okay. Because we cannot see only the chemical waste that is given by the industry. It can be maybe some local thing also, disposed of or something over there. So we use remote sensing, that is Sentinel-2 and Landsat 8 imagery for large scale water quality parameters. These two images, these two satellite data are, high resolution data. Okay. Sentinel-2 is what we get from the, what you say, Russian satellite data, and Landsat is US. Okay. GIS analysis, we use Google Earth Engine to do the analysis, that is image processing, and we use GIS to create the spatial maps. Google Earth Engine doesn't create maps, okay, but it can display. Fine, it can display at the time. But when you have to create maps and submit it somewhere, isn't it? GIS you have to use. And the outcome was monitoring water quality for sustainable urban plan. So this was a study area. You can see this is the Patalganga river. Okay, this is the upstream side where we have a dam. And this is the lowermost side. Okay, downstream side. So this is the Patalganga river. You can see this is the complete Reliance industry area. This is the MIDC, which I was talking about, and they have the central effluent treatment plant also. And what they say is they treat it and then they dispose it off to the river. Fine. And they also carry out the testing of the water quality. And what they get is they get standard. Within the standard, they are getting the results. But if you see here in the image, you can see this green. It is eutrophication. Because there's more nitrogen into it. त्याच्यामुळे ऑक्सिजन सगळे जातच नाही पाण्याच्या खालच्या पर्यंत तिथे प्लॅन्टन ग्रो. Fine. So this was completely visible from imagery itself. Because eutrophication is done, and hence there's some, suspended solids and nitrogen, high nitrogen content over. So traditional challenge, if we have to really test it, fine, photographs get it, and then we have to prove it with the time photos, and then that was very difficult. Again, if you have to check the water quality, तो पातालगंगा industry उसके अंदर जाने भी नहीं देते अगर पानी लेने के लिए sampling करना है तो they will not enter with all the permissions that you do. So it was time consuming, labor intensive, limited area coverage we would get. कहाँ से sample लेते हैं तो upstream का लेते हैं या फिर downstream का लेते हैं एक sample, continuous भी नहीं ले सकते थे. Fine. So this was the challenge. So objective was here we had only two. Fine. Rest we had done other things also, that is nitrogen content also. Here we just did only the basic thing, that is suspended solids and the turbidity levels. We assessed it with using the remote sensing data. Fine. We assessed it for at least 5 years. Fine. Okay. And we compared the observed parameters with the permissible limits that are given. And what are the insights? So this was the workflow. We data collected. We collected the Landsat and satellite sentinel data. We use the metadata, that is again you can see cloud cover, band selection, which area to be worked out, what filters you have to apply to remove or get the clear images, fine, which image types we have to configure, okay, because this whole complete area will not come in one tile itself. Again, as I said, it's scanning. But so all it सभी tiles में वो data आएगा नहीं ऐसे नहीं, complete एक tile में तो होता नहीं. So we have to select the image tiles and we have to merge it again, fine. Then we have to do the filtering. We have to find out the functions, do the filtering, use the algorithms to find out the normalized differential water quality index, NDVI, turbidity TS, and then the results. So these are the graphical results. GIS again gives you these graphical results also. So you can see here the time period from 2015 to 2021 and the turbidity levels. Okay. So there are peaks, there are lows. Okay. If you see the peak here, जून सितंबर में ही है, लेकिन यहाँ कम है. What was it? 2018, 19, 2021. Especially ये एरिया क्या, ये टाइम क्या था, कोरोना का. या फिर 2018, 19 में when we saw there was very much surveillance going on at that time. So industries were very quiet, Okay. Also there was not that rapid, what you said, growth happening. Okay, but if you see after this, again that's So this is one thing. So these were the findings. Seasonal trends we found out, interannual variability, and the occasional peaks. Fine. So occasional peaks we had done. Turbidity level varies year to year. Higher turbidity levels. The reason because of it, that is rainfall and sediment happens. Fine. Same way we did for total suspended solids. So we worked out that in the second half 2016, 2017, 18, fine, notably high levels we have. Okay. So you can see here the variation. You can study this variation and find out. Okay. Again, you can see January 2021 to 2023, potential decline in water quality. Fine. Total suspended solids were reduced. So this quality, water quality parameters were mapped. Okay. With the legends here, you can see IDTI values and all. You can see here, that is where it's dark, right? That was even in the image you see, that's the eutrophication happening. So there, total suspended solids are also high, turbidity was also high. So key findings, consistently high turbidity near the industrial levels and which is exceeding permissible use. What they FDP had given them was, it's within permissible limit. क्या करते हैं वो lower stream में कहीं पे पानी लेते हैं. Treated पानी जहाँ पे भेजते हैं वहाँ का पानी टेस्ट करने के लिए. How will they will get it ना? They have to take the water samples from the upper stream. यहाँ से ये शुरू होता है, isn't it? So that is the thing. Then seasonal variations, elevated turbidity during the July-September, which is very much okay. Long-term monitoring is needed because where there's total suspended solids and all, nearby that area only is suffering, a lot of problems because of this induced pollution. So this emphasizes the need for targeted pollution control. Fine, let's talk about that. So this maps with the letter was given to the stakeholders and some of the people over there, they took the lead, they arranged time campaigns, fine, they kept it, holdings of these maps, big maps and kept the letters and people were coming, those who are the residents there, they signed it and they submitted it to us. So this is how we can say from problem solving to real world, we can, put it. This is what typical place that we have to take it. We're happy to give it to more. But anyway, I will give this presentation to the organizers and you can go through some different case studies also that are put up over here. That is renewable energy के लिए solar radiation maps कैसे कर सकते हैं? Rooftop solar energy कोई given area के लिए कैसे capture कर सकते हैं based on how much the occupancy buildings का क्या है, buildings के height क्या है. तो अगर building का height ज़्यादा है, terrace पे solar reflectance ज़्यादा आ रहा है, तो वहाँ पे ज़्यादा capture होगा. So that way in kilowatt hours, the rooftop solar, how much can be captured for a given area. Okay, you can work out. Not only this, potential site for solar capture. Also potential site over that also we can do it. Right? So that is one case study that I have put up here. And for doing it, which satellite, remote sensing and GPS and GIS data you have to use is also explained. Thank you. What other parameters besides the turbidity and calculate? Yes, we have done for nitrogen content by using resistance. Yes. Yes. There are some what you say wavelength comparisons you have to do. In nitrogen and वो कौन से wavelength में water body का एक wavelength range में water body की wavelength range में अगर water में nitrogen है तो क्या wavelength spectral reflectance कितने range छोटा range होता है कितने range में so that we have to capture from that area कि कहाँ वो spots हैं. If we get a lot of density ज़्यादा है उस spots में that means it is having a high nitrogen. And with the real nitrogen content जो है इसका जो values है correlate. Directly नहीं मिला क्योंकि wavelength मिलेगा. You can correlate with the actual. There are correlations. Nitrogen we have, then we also do pH. But correlation. It doesn't give exact pH जैसे हम लोग test करते हैं. But whatever wavelength bands we get, we correlate with the pH. Yes. We have done temperature. What is surface temperature? In-depth नहीं मिलेगा, surface temperature मिलेगा.
What is the challenge?
As for combination presentation with major objective in the last 10 days, that you will do work around that topic. I just want to ask one question, whether we will use statistical data and inputting the spatial map, and then can we create an output regarding the quality?
Yes, why not? Definitely, like for example, you have water samples taken at specific points. वो point का coordinate है आपके पास. Water samples over the period you have taken, say complete year, उसका statistical calculations you can put it and create maps for complete water quality maps.
One is confusion is there. Whenever the river is flowing continuously, so whenever the water is a small body is there and not flowing continuously. Whenever we are adding some chemicals in the water body, we will show high contamination. Yes. And whenever it is flowing continuously, it will mix with the continuous water.
Yes,
and
yes.
Get the result. So is it change with the seasons?
So that's what we have shown. With the season, like daily season, you can see turbidity is high, total suspended solids is high. But again, if you notice it, it is high where the industrial areas are.
Okay, so as we
And when it comes to the downstream side, वो और dispose हो जाता है, कम हो जाता है.
okay, so what result can
Yeah, that is what the maps are showing us. What results say
on the basis of this result, can we say that the contamination is for cold year?
No. Here I have shown you contamination has taken.
Summer.
Yes.
Depending upon that type of that specific type of image.
Yes.
Okay, mixing with the
We
lab.
have to collect different time period key images. So here they have done it from 2014 till 2022. तो 2014 में जितने images मिलते हैं रेनी सीजन में मिले we cannot say कि सितंबर में ही सैटेलाइट वहां पे जाएगा. Fine. So whatever images we get there, वो कौन से टाइम पे लिया है accordingly we access. So कभी कभी एक साल में सितंबर में मिला है, इसमें जून में मिला है डेटा, but we process it accordingly. That is what data wise, image wise, time wise data लिया है. That is how it helps to know upstream में और downstream में stretch बड़ा होता है. But if you do it physically, तो upstream में जाके कभी कितने time पे water sampling ले. See, they dispose it at the night time. Satellite data से time भी मिलता है. So night time में you can see that here are shown only 2 images, but we have even bifurcated time wise. तो night time में जो images आते हैं, उसमें immediate जो TSS मिलता है, वो उसके बाद वाले कई images से कम होता है. So that is another finding which I have not shown it. Only when FDP calls us to present it, I'll definitely present it as a representative of the people. Yeah. So this is what I did in Goa actually, consultancy work. Goa में they had this coastal regulation zone applied. But then it was like from the shoreline, 200 meters तक आपके what you say natural material के अगर कुछ structures है, that can be there, that are not to be demolished. But concrete के अगर structures है, fine, that is constructed after 2019, so that are to be demolished. Fine, 2019 के पहले लेकिन concrete है फिर भी निकालना है, coastal regulation में है ही नहीं. Only natural material like that laterite rock के अगर आपके घर है with shades and all, you keep it as it. But not any artificial material like concrete, steel वगैरह वो नहीं रखना. वो 200 meters तक. 200 meters के आगे तो कोई भी structural ये नहीं रखना, only vegetative cover रखना is what their thing is. So one of my client उनका घर था वहाँ पे in that 200 meters, and he had got a notice कि it is to be removed, demolished. Okay, so he had put कि ये तो है ही नहीं, natural material है, and it is before 2019, like not only 2019 बहुत पहले से है. मेरे great grandfather ने construct किया, मैंने बस थोड़ा सा extend किया है. Even the extended material is no concrete, fine, but the structure was there even before 2009. उन्होंने 2019 से लगाया है CR2, लेकिन 2009 to 2019 भी वो structure वहाँ पे ही है, and it is very much from before that, and it is natural material, so you cannot demolish it. तो ये ट्रिब्यूनल को उनको एक्सप्लेन करना था तो what they said is 2009 to 2019 की पीरियड में वो स्ट्रक्चर है, तो उस वक्त का कोई तो जिंदा रहेगा उनका, उनके ग्रैंडफादर के साथ वाला, तो वो कहीं तो साइड करके देगा, yes I was there, I seen it. Fine, most of the people they did it. खोज ये है, जानते हैं, वो जानते हैं. The tribunal didn't accept that. नहीं ऐसे कुछ किसी का डॉक्यूमेंट लेके आना नहीं, आपको प्रूव करना है तो कोई इससे प्रूव करो कि वहां पे स्ट्रक्चर था. आम्ही आपण जो म्हणतो सातबाराचा उतारा, तो सातबाराच्या ह्याच्यात पण तो स्ट्रक्चर नसतो, ती जमीन आहे. So what to do? So then they approached me, and then the satellite data, remote sensing satellite data from 2009, say, for a period of every year, one satellite data, taking that, processing it. I just classified that yes, this is the settlement. उनका जो stretch है, वो settlement है. The thing was, they had a structure there, and आजू-बाजू का जो जमीन है ना, जब हम लोग रहते हैं, तो गांव में क्या होता है, हमारा घर है, उसके आजू-बाजू का भी जमीन हम लोग ना कन्वर्ट करते हैं, वो नेचुरल नहीं रहता है, isn't it? So वो एक एरिया है, वहां पे वो it is something man-made, it is altered, it is not natural. So we did it with the help of this image classification, supervised image classification, random forest, and we proved that that area fine is a settlement, and in that settlement only, क्योंकि मैं जाके वहां पे जीपीएस के कोऑर्डिनेट्स लेके आई, वो घर के 4 कॉर्नर्स के, वो कोऑर्डिनेट्स भी वही एरिया में, सेटलमेंट के एरिया में आते हैं, इसलिए उनका घर उस वक्त था. Okay. Also, the area that the wavelength band it came, it was not in concrete wavelength. It was very much in the rock and lee category. So material wise also it was proved it is a natural material structure. So the tribunal then, when the report, I as a consultant I can only give the reports and the findings. The tribunal then they told the client to call that person who did it and tell that person to explain. So I had to go there in the meeting there, and I had to present it, how it is and what we have done, what data we have used, and we used complete open source data, open source technology and open source satellite data that was available. Now the satellite data was available was 30 meters by 30 meters. Resolution 30 meters का था. उनका जो घर था वो 10 by 15 मीटर का था. तो मैंने जो सेटलमेंट वो 30 मीटर के रिजोल्यूशन में जो मेरे पास आया, उसी में वो कोऑर्डिनेट्स आए, कहीं तो वो उनका घर है वहाँ पे. So that is what the analysis that I did, what the techniques I used, I explained them, and then that IS officer was happy, and then he said his lawyer कि ये जो मैडम ने बोला वो एक पेज में लिख के हम लोग को दे. And this is how we did it. And the client, of course, he is a big construction. He has big construction portfolio there. At then what he said is, ma'am, what you did, isn't it? And what you're asking is peanuts. Like the fees that I asked was peanuts. Because yes, I'm in a government college, government aided institute, and hence my whatever findings I do is having a value, because it's not anything fake that the private, and that's the reason the tribunal had accepted it, because it came from a government institute. So that is how we can do it. So this many like small works I keep on doing it. Right now I'm working on Vedanta mining project in Goa. So they are Vedanta mining, they are having, towards the mining, they are having a road going from the jetty. Right? During the Portuguese time only, there was a contract there that this road, it's a mud road only, but this mining company can access this road for their transport of the materials. Okay, they have not built that road. It is still a mud road, but throughout this year they are using. Now there are mining restrictions there, but the company is still there. The company says we can still use that road, right? कोई और कुछ कंपनी में या कुछ और कुछ करो, लेकिन वो रोड तो मैं यूज कर सकती हूँ, मेरे पास परमिशन है, and I'm using it from long before, right? And I've not done anything on that road कि कुछ bituminous किया, कुछ नहीं किया. I have kept it as it is because that was the condition. So now the Vedanta is going in the court saying that we are using it from the Portuguese time. अभी Portuguese के time से तो हमें satellite data मिलेगा. We can get it max from 2000 2010. So they want to say कि 2010 में भी this road was there. Even here का settlements नहीं थे, तभी भी ये road था. अभी वो mud road ही है. But still it is an artificial type because it is big ramp. ये natural picture में नहीं आता. So my thing is only to work out कि this is something unnatural, fine, and this may be a murder. Is what I have to give you. So one draft report have been given. Now they have given me the GPS survey that they had because I wanted exact the road coordinates. So I told them that I require exact road coordinates. So they had done the GPS survey then. They had given that survey thing. And from the survey department, they have also asked the KML files which are the plots nearby. तो क्या हो गया वो नियर बाय जो प्लॉट्स है उन्होंने केस डाला है कि ये जो प्लॉट ये एरिया है ये रोड का ये हमारे इसमें आता है यू कैन नॉट यूज दिस they have to just okay ये पहले से आप ये आता है that doesn't matter to me it's with the government they have to say so this is what we do small little by little bit things yes any questions or anything you want to know
Any more questions? Thank you, ma'am. It requires meticulous planning and a bird's eye for presenting such detailing. We are fortunate enough to have that experienced in today's session. On behalf of each one present here, I would like to express my heartfelt gratitude and appreciation to you, ma'am. You have so effortlessly made us understand the difference between the geomatics and geospatial technologies. Also to mention